Welcome back to another exam walkthrough. We're going to be going to 2024 October, Unit 4, Question 17, Part B. So you can pause and try the question and then I'll solve it. So it says a toy airplane moves in a horizontal circular path of radius r at a constant velocity v. The thread is at an angle theta, so the vertical as shown. And then it says that the forward and backward forces on the toy airplane are equal in magnitude. Add to the diagram to show the other forces acting on the airplane. So they want us to show the other forces. So first of all, because of the thread, there's going to be a tension force. So there's going to be the tension on the aeroplane. That's going to be the first force. The second force is going to be the weight. So we're going to have the weight of the aeroplane. So you can just write it as T for tension and W for weight. And then in the part II, they tell us that show that the angle theta of the thread to the vertical is given by this equation. Okay, so for that, I think it's best if I draw a free body diagram first. So here is the free body diagram. And I've written one more thing here. In circular motion, the angle should be measured with respect to the axis through the center of the circle. Do not take the angle with the weight. Okay, so we know that the aeroplane is moving in a horizontal circular path, something like this. This is going to be the center of circle, and this is what I mean by the axis to the center of the circle. This is what I mean by that. Okay, and then you're going to draw a line like this, dotted line, and then this is going to be the angle theta. You can see that this is a Z angle. Okay, so that's going to be alternating angle, and then that's also theta. I want to place emphasis on this because some students, they make angle with the weight and then they get confused. So be careful with that. Okay, and now we can say that this is going to be T cos theta, and this is going to be T sine theta. And we can see that T sine theta is going to be the centripetal force. So T sine theta is equals to mv square over r, and T cos theta is equals to the weight. So I'm just going to copy this, and we're going to paste it right over here. And then we know that sine theta over cos theta is equals to tan theta, and that's what we're looking for here. Now, if you want to know where this comes from, if you're not a math student, then we know that sine theta, this is from IGCSE, is equals to opposite over hypotenuse. Cos theta is equals to adjacent over hypotenuse, and tan theta is equals to opposite over adjacent. Now, when I divide sine theta by cos theta, you can also write it as opposite over hypotenuse divided by a over h. The h here will cancel out, and we're going to end up with O over A, which is basically just tan theta. So that's basically the proof of that. Okay, so basically what we have to do, this is equation number 1, equation number 2, we divide equation 1 and equation 2. So we're going to do T sine theta over T cos theta, mv square over r over mg weight. Gets cancelled out, tt gets cancelled out. This entire thing will become tan theta, so you're going to get tan theta is equals to v square. This r will move down, rg. So that's going to be your answer. Okay, in the next part, they tell us calculate the time taken for the aeroplane to complete one revolution. The time taken to complete one revolution is the time period. And that's found in the equation omega is equals to 2 pi by t. So I will need the value of omega. Now, first of all, we can use the equation that we derived before. Tan theta is equals to v square over rg. They've given us the value of r, they've given us the value of theta, and we can find the value of v. So the value of velocity is going to be 0.9123 meter per second. That's the value of velocity. Now what we can do is we can take the velocity, and we know the equation v is equals to r omega. This is the equation that relates linear velocity with angular velocity. And now what you can do is we can do 0.9123 divide by 21 times 10 to the power of minus 2 to get us the value of omega. So the value of omega will be 4.34 rad per second, and then we can plug it in this equation. So t time period is equal to 2 pi over 4.34 rad per second. And then this is going to be rad, cancel out. And that gives me an answer of 1.446 seconds. I'm going to round that to 2SF because these things are given to me in 2SF. So rounding it to 2SF is going to give me 1.4 seconds. This is the first, second significant figure, the third significant figure. So that's going to be the answer. So I hope that was clear. Now I'm going to show you the mark scheme and the examiner report, and that's all for this video.